this short video, I'm going to use to show you how to basically compute a probability distribution using StatCrunch. So what we're going to do is we have to find where to do this. We're going to go to Stat, Calculators, Normal Distribution, or a normal curve. And when I click on there, I should get this information to show up. I get a bell curve that's right here for us to use. Now, what's going to end up happening is as I'm taking a look at this, I have a mean of 0, a standard deviation of 1, and right now it's at 50%. So the red part is colored in because I am less than 0. The probability of less than 0 is 50%. If I switch this to greater than, it will color the right-hand side. Now, what you see right now is the tick marks of the normal distribution, 0, 1, 2, and 3, -1, -2, and -3. That's because I have a mean of 0 and a standard deviation of 1. So if I ever said, what's the chances of a probability of greater than, say, a z-score of 1.25, so if I put in 1.25 and I hit compute, there's my 1.25, so the probability distribution says there's a 10.56% chance it's greater than that. I can very easily switch it to less than that, and it will give me the complement of 89.43. So if I have a z-score, I want to use a 0 and a 1, and I just plug in the z-score right here. But you could also use this if you want to do just straight data. You can turn around, let's say my average is 500, and my standard deviation is 50, okay? I now can turn around and say, what's the chances I can find a score above or greater than 540? I can hit the compute, and it does the z-score for me. So in other words, if a mean is 500 and a standard deviation is 50, the probability that I get a value that is greater than 540 is going to be 21.18%. If I switch this to less than, I can easily do it that way, and that's a complement of 7881. So I can either use raw data of 550, or I can use the z-score. If I compute a z-score, this would be where 0 and 1 come into play. And when I hit compute on that, it will not give me anything because I have to type in a value, and now it'll be on the scale of 0 to 1. Now that's standard if you want left greater than, or left less than, or right greater than. If I click the word between, you'll notice here that I now have different options. I have two values to put it in. So the chances between -1 and +1 is 68, which follows along with our 68, 95, 99 rule. So if I change this to -2 and 2, it will show me the 95. And if I change it to -3 and 3, it should show me the 99.7. So all I have to do is if I have two different z-scores, let's say I have a -1.23 and the other one is going to be 0.59, if I hit compute, it will tell me there's a 61% chance falling between those two scores. That's because I have a z-score, and a z-score means I have to put in a mean of 0 and a standard deviation of 1. But if I have raw data, let's say for example I have raw data that the average is 500 and the standard deviation is, let's say, 20, what's the chances I'll get a score between 450 and 510 when I compute that? Well, if the mean is 500, 450 would fall right here, 510 would fall right here, so it basically computes the z-score for you, does the math, and says there's a 68.5% chance you'll fall between the 450 and the 510 mark. So if you have just straight data, you can plug in your mean, you can plug in your standard deviation, and you plug in your straight scores to get the percent. If you don't want to do that and you want to convert to a z-score, you just make sure that you have it between a mean of 1 and a standard deviation of 1, and when you hit compute, it will give you values between 1, 2, and 3, -1, -2, and -3. So that's how you can do the probability distribution. How you can use that in lieu of the table can help speed things up for you if you have this open while you're doing your work. But it is not the only way to do it. It's just one option for you to do. So hope this video helped. Let me know if you have any questions.